Someone taught you that mathematics began in ancient Greece. They taught you about Pythagoras and his theorem. They taught you about Euclid and geometry. They taught you that the Greeks were the fathers of mathematical thought, that reason and number were born in Athens, that the story of human calculation started somewhere along the Mediterranean coast of Europe. They were wrong. And the proof has been sitting in a museum in Brussels for over a century. It is called the Ishango Bone. It was discovered in 1950 by Belgian geologist Jean de Henzelin de Brocourt on the shores of Lake Edward in what is now the Democratic Republic of Congo. It is a baboon fibula, roughly the length of a hand, covered in a series of deliberate, carefully organized notches arranged in specific groups along 3 columns. It is approximately 20,000 years old, and mathematicians and historians of science who have studied it closely believe it is the oldest mathematical object ever found. Not a calendar, not a tally, a mathematical tool. The notches are not random. They follow patterns consistent with multiplication, prime numbers, and a base 10 numerical system, the same foundational system that underlies virtually all of modern mathematics. 20,000 years ago, in Central Africa, someone was thinking mathematically, not scratching in boredom, not counting animals. Thinking, organizing number into pattern, into system, into something that could be transmitted, used, and built upon. That someone was African, and the object they left behind predates ancient Greece by more than 15,000 years. Let that land for a moment. When the mathematicians of ancient Greece were working out their theorems, they were not inventing mathematics. They were inheriting a tradition that had been developing in Africa for millennia. A tradition that traveled north through Egypt, through the Nile Valley knowledge systems your ancestors built, and into the Mediterranean world that would later be credited with creating it. But the Ishango Bone is only the beginning. In 1937, a wolf bone was discovered in Czechoslovakia covered in similar notched tallies dating to around 30,000 years ago. Historians called it a tally stick and moved on. When the Ishango Bone was discovered 13 years later with far more complex and organized markings, the same historians called it a calendar and moved on again. It took decades of persistent scholarship, much of it by African and African-descended researchers, to establish what the evidence clearly shows, that the Ishango Bone represents early mathematical thinking, that Africa was not on the periphery of the story of human intellectual development. Africa was where that story began. Now let us talk about what came next. Because the Ishango Bone was not an isolated moment of brilliance followed by silence, it was the beginning of a continuous tradition. The ancient Egyptians developed one of the most sophisticated mathematical systems in the ancient world. The Rhind Mathematical Papyrus, an African document dating to around 1550 BCE and believed to be copied from an even older source from around 2000 BCE, contains 84 mathematical problems covering arithmetic, algebra, and geometry. It includes methods for calculating the area of a circle using a value for pi accurate to within 1% of the modern calculation. It contains solutions for linear equations. It demonstrates an understanding of fractions so sophisticated that it influenced mathematical notation for centuries. This was not primitive calculation. This was a developed, applied, institutional mathematical tradition, recorded, taught, and refined within a formal system of African scholarship. And here is where the story of credit becomes impossible to ignore. Thales of Miletus, widely credited in Western textbooks as the founder of Greek mathematics and the first philosopher to use mathematical reasoning, traveled to Egypt to study. This is not disputed. Ancient Greek sources themselves record it. He brought back mathematical knowledge from the Nile Valley and introduced it to Greek intellectual culture. Pythagoras, whose theorem your children will learn in school as a Greek invention, also studied in Egypt for an estimated 22 years. The theorem that bears his name was known and used by Egyptian architects and engineers for at least 1,000 years before Pythagoras was born. The relationship between the sides of a right triangle, what we call the Pythagorean theorem, appears in Egyptian construction documents, in the proportions of temples, in the measurements of the pyramids themselves. Pythagoras did not discover this relationship. He encountered it in Africa, formalized it, brought it back to Greece, and had his name attached to it by subsequent generations of European historians who were building a particular story about where knowledge came from. Scholar George G. M. James documented this extensively in his landmark work Stolen Legacy, arguing that what is called Greek philosophy and Greek mathematics is in large part Egyptian, which is to say, African, philosophy and mathematics, transmitted through Greek students who studied at African institutions and returned home with what they had learned. This is not a fringe argument. The archaeological and documentary evidence supporting the African origins of mathematical thought is overwhelming. Consider what this means practically. When you balance your finances, you are using a numerical system whose foundations were laid in Africa. When an architect calculates the load-bearing capacity of a structure, they are applying geometric principles that African engineers were using to build the pyramids 4,000 years ago. When a programmer writes an algorithm, they are working in a tradition of systematic mathematical thinking that began on the shores of a Congolese lake 20,000 years ago. The abstraction you call mathematics, the language of science, the foundation of technology, the tool that built the modern world, has African fingerprints on its oldest and deepest roots. And this matters not just as history. It matters as identity. Researcher Ron Eglash at the University of Michigan spent years studying mathematical patterns in African cultural practices and documented something extraordinary. Fractal geometry, the branch of mathematics that describes complex, self-repeating patterns, only formally developed in Western mathematics in the 20th century, had been embedded in African architecture, textile design, village planning, and artistic practice for centuries. Not accidentally, intentionally. African designers and builders were working with fractal mathematical principles long before European mathematics had a name for them. Your ancestors were not behind the curve of mathematical development. In many areas, they were so far ahead that the rest of the world has only recently caught up to what they were already doing. The next time someone tells you that mathematics is not for you, that it is somehow foreign to your heritage, that your people were not mathematical thinkers, you can tell them about a baboon bone covered in deliberate notches found on the shores of a Congolese lake. You can tell them it is 20,000 years old. You can tell them it belongs to your ancestors. And you can tell them that the next time they solve an equation, they are standing on a foundation that African hands built first. The Greeks got the credit. Your ancestors built the house.